Ever wonder what the ultimate global disaster movie would look like? Is it a giant space rock hurtling towards Earth, or a colossal volcano erupting from beneath our feet? Hollywood loves both, but which one is the bigger, badder threat in real life? Today, we're pitting asteroid impacts against supervolcano eruptions in a showdown of planetary proportions. Which one poses the greater risk to humanity? Let's dig in and find out. First up in the red corner, we have the cosmic contender, the asteroid. We've all seen the movies, a fiery messenger from space, screaming through the atmosphere before impact. The most famous example, of course, is the Chicxulub impactor. This beast was about 10 kilometers, or 6 miles wide. It slammed into the Yucatan Peninsula 66 million years ago, and well, it was a very bad day for the dinosaurs. The initial blast would have been unimaginable, creating a crater over 150 kilometers wide and vaporizing everything for hundreds of miles. But the immediate explosion is only the beginning. An impact of that scale throws trillions of tons of dust, soot, and sulfur into the atmosphere. This debris cloud would spread around the globe, blocking out the sun for years, maybe even a decade. This is what we call an impact winter. Photosynthesis would grind to a halt. Plants would die, food chains would collapse, and global temperatures would plummet by as much as 25 degrees Celsius. It would be a worldwide deep freeze. On top of that, you'd get continent-sized wildfires, mega tsunamis thousands of feet high, and acid rain that could make the oceans as corrosive as battery acid. The dinosaurs never stood a chance. The good news? An impact of this size is incredibly rare, happening maybe once every 100 million years or so. But what about smaller asteroids? A rock just 1 kilometer wide would still be a global game-changer. It wouldn't cause a mass extinction, but it would trigger an impact winter severe enough to cause worldwide crop failures and famine. Think of it as a year without a summer, but potentially lasting much longer. We call these civilization enders. Even smaller ones, say 140 meters across, wouldn't cause a global catastrophe, but could wipe a major city off the map with the force of thousands of nuclear bombs. And there are a lot more of these smaller ones out there. NASA and other space agencies are actively tracking these near-Earth objects, or NEOs. We've found most of the big dinosaur killers, but we're still searching for many of the smaller, city-killer-sized ones. The great thing about the asteroid threat is that, in theory, it's preventable. If we find one on a collision course early enough, we could potentially deflect it. NASA's DART mission was a successful proof of concept, showing we can change an asteroid's path. So, we have a defense, even if it's still in its early stages. Now let's turn our attention to the challenger from down below, hiding in plain sight. The supervolcano. Forget what you think you know about regular volcanoes. A supervolcano is a completely different beast. It doesn't form a classic cone-shaped mountain. Instead, it's a massive underground chamber of magma, sometimes dozens of miles across, that builds pressure over hundreds of thousands of years. When it finally blows, it doesn't just erupt, it detonates. The ground above the magma chamber collapses, creating a vast depression called a caldera. And the eruption itself is what scientists call a VEI 8 event, the highest possible rating on the Volcanic Explosivity Index. The most famous supervolcano is right under Yellowstone National Park in the United States. Its caldera is so huge, you can only see it from space. Yellowstone has had 3 super eruptions in the last 2.1 million years, roughly every 600,000 to 800,000 years. The last one was about 640,000 years ago. So, are we overdue? Well, overdue isn't really how it works. These are just averages, not a fixed schedule. But when it does go, the consequences will be biblical. The initial blast would be thousands of times more powerful than the Mount St. Helens eruption. It would instantly obliterate everything within a 100-mile radius. A thick layer of hot volcanic ash would rain down across thousands of miles. We're talking several feet of ash covering entire states, enough to collapse buildings, contaminate water supplies, and turn fertile farmland into a barren desert for generations. Just like with the asteroid, the real global threat is what happens to the atmosphere. A super eruption would inject massive amounts of sulfur dioxide into the stratosphere. This gas forms a haze that reflects sunlight back into space, triggering a volcanic winter. Global temperatures would drop by 5 to 10 degrees Celsius for several years, This would cause catastrophic crop failures around the world, leading to widespread famine and the collapse of society as we know it. The last super eruption on Earth was Toba, in Indonesia, about 74,000 years ago. It was so massive that some scientists believe it pushed early humanity to the brink of extinction, creating a genetic bottleneck from which we barely recovered. Unlike an asteroid, there is absolutely nothing we can do to stop a supervolcano from erupting. We can't plug it, we can't relieve the pressure, all we can do is monitor it, and if we get enough warning, try to evacuate. But how do you evacuate a continent? So let's bring it all together for the final verdict. Asteroid versus supervolcano. Which is the bigger threat? Let's look at the facts. In terms of frequency, major super-eruptions like Toba or Yellowstone happen roughly every 100,000 years. Dinosaur-killing asteroid impacts are much rarer, maybe once every 100 million years. So, statistically speaking, a supervolcano is the more likely event in any given time frame. In terms of impact, both are catastrophic. Both can trigger a global winter, mass famine, and societal collapse. A giant asteroid impact is probably more devastating in its initial violence, the mega tsunamis, the sheer explosive force. But a supervolcano's lingering effects, like rendering vast swathes of land completely uninhabitable for decades under feet of ash, are uniquely terrifying. But here's the crucial difference: predictability and prevention. We can see an asteroid coming. With enough warning, we might be able to do something about it. Our technology for planetary defense is growing. For a supervolcano, our warning signs might only be weeks, months, or maybe a few years at best. And even with a warning, our only response is to run. There's no deflection, no mission to save the day. We are powerless against the forces rumbling beneath our own planet. So, while the cosmic cannonball of an asteroid makes for a more dramatic movie plot, the silent, ticking time bomb of a supervolcano is arguably the more realistic and insidious threat to our civilization. It's not a question of if another super eruption will happen, but when. It is a sobering reminder that some of the greatest dangers we face come not from the vast emptiness of space, but from the very ground we stand on. What do you think is the more terrifying scenario? Let me know down in the comments. And if you enjoyed this deep dive into planetary threats, be sure to hit that like button and subscribe for more content that makes you question everything. Thanks for watching and stay curious.